Hey, I'm Trent, and joining me today is Jack, and we're on the platform team at Mothership. We're going to tell you a story.
What if I told you we eliminated static AWS credentials from developer machines, eliminated static Kubernetes credentials from developer machines, eliminated static database credentials from developer machines, and kept our databases behind a firewall? It sounds nice, right? Well, when I joined Mothership, the entire service was built off of Firebase and Heroku. Any databases we had were public, and developers could fetch all production secrets. Over the last year, we containerized our apps, deployed them into EKS, and started to migrate data out of Firebase and into RDS Postgres. While there are a number of things we'd love to share about our experience so far, today we're going to focus on our approach to database management and how we leverage Crossplane to get rid of shared database credentials. As fitting for a Kubernetes talk, let's start with our desired end state. We wanted all of our databases to have a shared baseline of users and roles. We didn't want our apps using the super user, for instance. We wanted to keep our databases behind a firewall so that a misconfiguration of our VPN or ingress wouldn't expose our databases outside the cluster. We didn't want to provision new databases on behalf of our developers. We wanted to give them that control, the same way that they can declare that they need an ingress or load balancer for their services. And lastly, we didn't want developers sharing passwords to the databases. In practice, this meant we needed a couple components. All of our apps were deployed via Helm charts, and spinning up a database with a CRD just felt natural, so we'd need an operator. Once the RDS instance was spun up, we'd need a worker process to bootstrap some common users and roles into the database, and spit secrets back into Kubernetes. And lastly, we'd need an authenticated Postgres proxy, both to get developers past the firewall and to make it a passwordless experience.
As it pertains to an operator, we want it to create an RDS instance in AWS, and most or all of the configurable options should be available. We need it to provide us with the master credentials and secret format in cluster, and we want status updates that will be used to trigger the post-provisioning process. We'd also like for it to support brownfield RDS instances, and hopefully it'll be written in Golang, because that's what we work in, and it'll be actively maintained. Upon evaluating the various options available to us, all of them had some requirement misses and required not insignificant time investments to get up and running, with the exception of Crossplane. Crossplane keeps the source of truth as a Kubernetes resource and allows us to subscribe to changes on that resource. Additionally, future platform initiatives involving other AWS resources could also leverage the framework, and it's actively maintained and written in Golang. The post-provisioning process needed to set up our permission structure, such as roles and role inheritance, revoking default public permissions, and creating the developer-specified application users, outputting connection strings to the right key and the secret they wanted it pushed to. Our application uses cache informers to listen to RDS instance status updates, creating jobs as needed to apply migrations to RDS instances, whether there's new migrations or a new resource that needs all migrations applied. It also binds application user credentials to specified output secrets and keys. We use jobs to ensure the work is done properly and not terminated prematurely. So far, we have Helm templates that render out RDS instances and security groups, as well as dictating application users and where the connection string should be output to. We also have an application that watches for RDS instance updates and creates a job that applies our permissions migrations, creates the roles and users, as well as outputting new user credentials to the targeted secrets.
I mentioned that our databases are firewalled off. In order to get around the firewall, we built and deployed a proxy in cluster that will connect to the databases. This also gives us a central point where we can add our own authentication layer, or log the queries being run against the database to maintain an audit trail. Now, developers could use the Kubernetes CLI to set up a port forward to the in-cluster proxy, but that wouldn't eliminate passwords. To solve this bit, we introduced a second proxy and took advantage of RDS IAM authentication. If you haven't used it before, RDS IAM authentication allows us to generate temporary database passwords tied to the developer's IAM identity. It does require you to set it up after the database is spun up, but in our case, this is part of our post-provisioning step. As for the local proxy, it sets up the port forward for the user, but it also intercepts the authentication messages from RDS and injects the password generated with their IAM identity. From the developer's perspective, they connect to a localhost port without a password and are on their way. From an operations perspective, we can now manage database access with IAM policies and never give out passwords to developers.
In the future, we're looking to open source some of the tools we've created to enable this workflow, as well as, provided we get bandwidth, see where Crossplane's provider SQL can fit into our post-provisioning process, and, if needed, contribute required features back to the project. Now that composition support is maturing, we're also looking at adopting the open application model into our platform. We're also planning on using additional Crossplane resources as our platform grows. We'd like to thank Crossplane for giving us an opportunity to share our story about how we handle database management and how we've been utilizing some of their product offerings.